Hello and welcome. We are presenting here our OS project based on scheduling algorithms under the guidance of Dr. Rutvi. In this presentation, we'll be providing you with both visual and verbal explanation of four important algorithms used in computer science and operating system, namely round robin algorithm, Banker's algorithm, scan-C algorithm, and MRU algorithm. Before the main implementation part, let me show you our landing page. As you can see, this is the landing page of our website. Now, if I click on Explore Now, it will not allow me as I am not a registered user. So, I have to register myself first. So, to register yourself in our website, you have to click on this register. Now, this registration form came and you have to fill the details. Now, after filling all the details, when I click on register, I registered myself on our website. Now, with these login details, we can explore our implemented pages. The user password is also stored in encrypted way, so no one except the user can access the website with his or her information. The user authentication is also one of our X factors. We store user login sessions to make our website more secure by using various web2 keys. In this, we have used bcrypt.js by hashing password with salting of 10 rounds. Now, let me show you the documentation part of the four algorithms. Firstly, round robin. This is the documentation part of round robin algorithm. Characteristics, how it is implemented, advantages, disadvantages. And we have also provided a video explanation for the same. Same for the Banker's algorithm, characteristics, safety algorithm, advantages, disadvantages. Same for scan and MRU algorithm. Characteristics, advantages and disadvantages. Now let us see the implementation part. Firstly, let's explore the round robin algorithm. Round robin algorithm is a CPU scheduling technique in which each process is given fixed quantum time and the CPU switches between the processes once the time quantum has elapsed. It is a preemptive algorithm that ensures all processes are given an equal amount of time. So, in this example, I have provided the file name Vedic. Quantum time, let's suppose we took 4. Arrival time 3. First time 2. Now we add the process. As you can see, the process is added. Now we add another process. So we added 3 processes. Now we execute and the output table is shown here. Here is the Gantt chart for the given input and the average completion time, average turnaround time, average response time, average waiting time and CPU throughput value. The Banker algorithm is resource allocation and deadlock avoidance algorithm used in computer operating system. This algorithm considers the current state of the system, the resources currently available and the future requests that may be made by other process. Then it calculates whether the request can be granted safely or whether it should be denied to avoid a potential deadlock. So here let me say the file name to be Vedic. The total resources of A 10, B 5 and C 7. Let me add the processes. So I have added the 5 processes as you can see in the input table. Now let me execute it and the remaining resources after each round is given in the table. Deadlock avoided successfully. The safe sequence is P1, P3, P4, P0 and P2. This is the chart division and this is the chart based on the input and outputs. Let us see the third algorithm, which is scan and scan-C. Let's discuss scan algorithm. It is also called as elevator algorithm. In this algorithm, the disk arm moves into a particular direction till the end, satisfying all the requests from coming in the path, and then it turns back and moves in the reverse direction, satisfying requests coming in its path. It works in a way an elevator works. Elevator moves in a direction completely till the last floor in the direction and then turns back. In C-scan algorithm, the arm of the disk moves in a particular direction serving requests until it reaches the last cylinder. Then it jumps to the last cylinder and opposite direction without serving any request. Then it turns back and starts moving in that direction serving the remaining request. Now let's say the file name to be Vedic. Total number of tracks are 200. Starting position is 50. Time taken is 41. Now these are the input table, and on execute we get this process tracks. When the details, total track travels are 226 and total time taken is 226. The chart is given below. Now let us discuss the last algorithm, which is MRU. MRU, most recently used algorithm, is a page replacement algorithm used in computer operating system. It works by selecting the page that has been most recently accessed for replacement. The idea behind MRU is that the page that has been most recently used is likely to be accessed again soon, so it should be kept in memory to memorize the number of page faults. When a page fault occurs, then the operating system checks the page table to determine which page is to be replaced. If the MRU algorithm is being used, the page that has been most recently accessed will be selected for replacement. So let me say the file name to be Vedic. Number of frames was 4. Page. Okay, so in details we can see the total number of hits is 8, the total number of misses is 10, ratio of hits is 4.44 and ratio of miss is 5.55. Here is the memory allocation and the table for the hits and miss. Let me show you the X factor in our website. We have integrated ChatGPT API Test DaVinci 3.4 model to answer users' real-time queries related to OS. We have implemented this in such a way that it only allows user to ask questions regarding OS and other queries are not being entertained. This is our help bot. So let me ask it a question like, what is round robin algorithm? So by using ChatGPT API, it will provide me the answer to the particular query related to OS. So this is the X factor in our website, which is HelpBot. In conclusion, we invite you all to try out our website and algorithm and provide feedback to help us improve the user experience. We also express our gratitude to our team members and mentor Dr. Rutvik Javeri for their contribution and support throughout this project. Thank you for all your attention and we welcome any questions or feedback you may have. Thank you.